The techniques of early neuroscientists did not include MRI, CAT scans, PET scans, or any other type of neuroimaging that we have today. Post-mortem examination of patients who'd suffered from a head trauma or showed significant behavioral deficits served as the first case studies. Well-known patients include Phineas Gage, who had an altered personality following a rail spike entering under his cheek and exiting above the frontal lobe, and Paul Broca's patient, LeBorn, who was unable to produce speech. Although researchers made attempts to create a functional map of various brain regions, it would be lesion studies that aided in describing the behavioral effect of brain damage. The lesion, or ablation, was made in a specific region of the brain, and behavioral tests and strict observation were made to discover the function of that particular region. Such studies have been conducted on numerous areas, including the hippocampus. The hippocampus is an integral part of a system of structures in the medial temporal lobe important for mammalian memory. The hippocampus receives projections from the neighboring perirhinal, parahippocampal, postrhinal, and entorhinal cortices. Damage to this region has been shown to hamper performance in tasks of learning and memory in rodents, non-human primates, and humans. Additionally, spatial navigation is believed to be a special ability housed within the hippocampus. The hippocampus's role in spatial memory has been confirmed by numerous studies, including those which have measured firing of single neurons on rats while allowed to explore an area. Researchers recorded firing of single neurons when the animal moves about the same region in the area. This indicates that the brain is able to detect that it is returning to an area recently explored. A computer can then show the firing rate of the neuron as a function of the area, with the red areas revealing higher rates of firing. If we were to then expand our scope and look at other neurons, we never see the same firing pattern. If we take the view of these multiple neurons, we can see where an animal is able to detect where it's been and whether it's returning to an area that is recently explored. One of the most frequently used tests in behavioral neuroscience, the Water-Morris maze, requires its rodent subjects to use spatial navigation in order to locate a submerged platform. We will be using a play on this water maze called the sand maze. Stereotaxic surgery was a central part of our experiment, in which one subject received a bilateral hippocampal lesion and a second underwent surgery but received no lesion, thus a sham lesion. The images show the various steps of surgery, from setup and the initial incision to the inscribing of coordinates, lowering of the electrode, and suturing of the animal. To assess the spatial memory of the rodents, we use the sand maze, an appetitive version of the water maze. A kiddie pool serves as the arena for the test, which is filled with a large bag of play sand, requiring the animals to dig for buried reinforcers. The specific food chosen for our experiment was a children's cereal, Fruit Loops. Placed at different depths, the food-deprived rats were to use extra maze clues in order to locate the food, allowing for measurements of their spatial ability to be recorded and later scored by the researchers. This is an image of the testing room. Sand maze is found centrally, surrounded by a total of 4 extra maze clues, 2 of which were provided specifically by the researchers. Circled in red, the black and white images, zigzag and circles, both serve as extra maze clues. In addition, the camera used to record testing sessions and a nearby Water-Morris maze also served as clues to the animals. Following 1 week of food deprivation, shaping trials lasting 3 days taught the subject to begin to dig for buried Fruit Loops. On day 1, the reinforcer was placed on top of the sand. On day 2, the cereal rings were buried halfway, and on the final day, a shallow bury required the animals to dig for the reinforcer. Training trials, lasting approximately 4 days, featured a burying of the Fruit Loops. The reinforcer was placed deeper and deeper into the sand following a successful trial. Completion criteria held that the animal must find the Fruit Loops within 2 minutes in half their trials, in order to move on to the probe trial, Although no animals were able to reach the probe trial, it served as a measurement of spatial memory, whereas the shaping and training tasks measured spatial learning. The sand maze task allowed us to measure 4 key behaviors: latency to locate the Fruit Loops, time in the correct quadrant, time in the perimeter, and rears. This overhead view will be used to explain the 4 behaviors. Latency to locate the Fruit Loops was simply that, the time it took the animal to locate the Fruit Loops. Looking at the maze, we were able to separate it into 4 different quadrants. Food was always placed inside one of these quadrants, and if the animal was inside that quadrant where the food was placed, it was deemed the correct quadrant. In perimeter, the animal simply spent time along the outside of the arena versus the inside. In this short clip of Percy, our Lesion rat, we see rears, where he is on his hind legs inspecting from the inside of the cage, and also movement along the perimeter before he heads towards the treat. Repeated measure ANOVA were conducted to analyze differences across the course of the experiment between the 3 animals. Analysis of the shaping trials, which were designed to teach the animals to dig for buried reinforcers, revealed no significant differences on any of the 4 behaviors measured in the sand maze. Training or testing trials saw only one significant result: rears, believed to be an exploratory behavior and attention away from the main task. The central measure of the experiment, latency to find the Fruit Loops, was not significant, although it had been hypothesized that Percy, the Lesion rat, would perform worse or have a higher latency as compared to the control and sham rat. Future replication of this study would want to utilize more animals, as our non-significant findings may have been due in part to the small sample size. Lack of criteria in the shaping trials, a portion of testing critical for the learning of rats to dig for barrier reinforcers, may be at fault for the later non-significant findings in the testing stage. Crushed Fruit Loops were added to the maze to ensure the animals were not using olfaction to locate the food, but, as seen in this clip, some pieces were quite large, and the rats searched for these instead of the buried rings. Food deprivation occurred throughout the study, but it was very difficult to maintain the weight loss during the study, making it a possible confound. Because we were unable to find any significant results, especially in the lack of difference in the latency behavior, we cannot say that the sand maze is a valid assessment of spatial learning and memory, although our Lesion may have missed the intended target. Oops.
Okay, go.
Are you ready, or are you just sitting
Yes.
around? What do you think?
Will you just do my ass?
Huh? No, it's me.
You guys both did the same thing.
Because we're supposed to be focused on the rat, not pictures of ourselves. Are you happy?
No.
Are you ready?
Serious. What happens if he dies? What are you gonna do?
That's not going to happen. I've never lost a patient.